Good afternoon. My name is Rrezarta Krasniqi, and today I will be presenting a paper recommending bug fixing comments from issue tracking discussions in support of bug repair. So, what is the major problem in this that I will be discussing is that one of the common strategies that developers use to fix open source bug reports is to go over past solved bugs and issue discussion threads to fix a new bug. However, with current trends and increase of bug data and social media, there are two major challenges that have become evident, such as time dimension and the content dimension. When we talk about the time dimension, obviously developers are overwhelmed daily with thousands of bug reports reported, and usually this is time consuming, inefficient, and obviously becomes an unattainable task. But in this paper, we mostly will be focusing on the content dimension. And so, in this regard, so as you know, in practice, developers search for related earlier bugs and their associated discussion threads when faced with a new bug to repair. Usually these discussion threads consist of comments and even bug-fixing comments intended to capture clues for facilitating the investigation and even the root cause of a new bug report. However, over time these discussions can become extensively lengthy and difficult to understand. These discussion threads lead sometimes to instances where bug-fixing comments intermingle with seemingly unrelated comments. So this task poses even further challenge when dealing with high volume of bug reports, and then often also large software systems, as I said, are plagued with thousands of bug reports. So time dimension also become part of the complexity in this aspect, and even the level of bug severity. And also developers and end user carry different backgrounds, which adds another layer of complexity. So to handle this problem, we automate this process. We propose a novel approach that we call it RetroRank, that efficiently and effectively recommends and extracts most relevant bug fixing comments from cross-cutting discussion threads of past solved bug reports retrieved according to the query relevance, positive language, and semantic relevance. You might pose a question: why we specifically picked these three associations in the context of solving the bugs? Well, in my experience as a developer before, one thing that I encountered, or at least I was able to see as a pattern, usually by looking at or different tickets for different systems, is that sometimes the discussions the developers or prior developers have done with each other is that the comments that they usually were more useful and informative, and at least gave also the solution to the problem, they became more and more positive towards the end as they were discussing the problem. So, and then they also use different keywords or terms that associates with the same thing. So by using this idea, I thought that using sentiment analysis and text rank model, together with vector space model, it would come up to be a good solution to extract only certain comments with specific characteristics, such as in this case. So basically, RetroRank recommends a list of comments by leveraging a combined weighted function, where keywords weight of each comment are influenced by scores obtained from combination of VCM, SA, and TR, meaning sentiment analysis, text rank, and vector space model. So here we have an example of how my tool works. So on the left side we have a bug ID 34600 that needs a fix. Obviously it's a problem in LibreOffice. One of the cells is not working properly. So what a RetroRank does, it uses a holistic approach and extracts certain comments with properties of positive language and semantic relevance and the query relevance from different discussion threads of different past solved bug reports, and it puts it together in a more concise and organized format so that developers can look at them and ranks, and what's even more important, it ranks them in the order that it makes it easier for developers to follow through and sort of filter certain comments rather than looking at thousands of comments. So in this case, these are most relevant comments that developers can use, in fact, to solve bug 34600. And as you see, these comments not only are positive and relevant, they also show information such as links to duplicate bug reports and instructions and guidelines to specifically how to fix this bug. Now, you might ask why we choose these recombination of techniques is that using one of the techniques independently, they suffer from some of the characteristics or the strengths that, let's say, text rank or sentiment analysis offers. So using VCM was not enough. So that's why the combination of 3 techniques actually produced better results towards the end. The RetroRank high-level design is at least consists of 4 blocks: the data collection and preprocessing step, the keyword extraction and comment computed scores, adjusted keyword scores, and retrieved comments. Basically, the most important part is the keyword extraction and comment computed scores and adjusted score, because here is where we actually compute keywords using text rank and then sentiment analysis, and then we use those scores to boost the initial scores from VCM. And that's why we would get certain comments to be at a higher ranking than others. For example, positive comments would be probably at the very top, while the negative comments would actually be towards the end of the list. So the boosting works for increasing the ranking for positive ones and decreasing the ranking for negative ones. And this is the GUI representation of the tool that I created. I wanted to make it very user-friendly so that in the future it can be used not only for the developers, maybe for future companies as well. So we performed an evaluation by using 2 types of studies, the synthetic study and the user study. The synthetic study was mostly done in a laboratory, in a small setting. What we wanted to do was to come up with we wanted to see if our tool compared to any of the techniques separately, does it perform better? And then we wanted to see also the orthogonality between SA and TR. Is there any difference between those 2 or not? And then finally, the third question, which is to what extent do comments retrieved by baseline and our approach differ in relevance as perceived by expert? This is a longer user study that is conducted in a larger setting once we got some results on the synthetic study. So let's look at the synthetic study methodology. So the synthetic study methodology actually consisted of 4 steps. On the first step, we manually identified the gold set of bug reports and their corresponding bug fixing comments. On the second step, we generated user queries for each report. And then step 3, we used the user-generated queries to run each configuration. And we computed metrics to measure the performance of each configuration. Though you must note that we use the same query that a user created, and we ran that same query for each of the configuration. So that way we didn't want it to leave any space for biases. And then for the synthetic study, we used the metrics and statistical test to measure the performance of our tool. Specifically for ranking, we counted the position where the gold set appeared in the retrieved list across all configurations. We also compared the ranking position to evaluate which of the configuration performed better. And for the orthogonality, we measured the ranking differences of the results returned from VCM, SA, and TR versus ranking differences of the results returned from 2 variants, specifically VCM plus SA and VCM TR, meaning VCM plus sentiment analysis and VCM plus text rank. We used the student t-test to evaluate the statistical significance of differences in ranking and orthogonality of each configuration. We also used the map mean average precision, because we wanted, which is considered average ranking position of each relevant comment. We wanted to see how effective was the ranking performed by each of the approaches. And then here we show more precisely the results obtained. So we have here different 25 queries entered with specific bug ID, and then we run that same query for four different open source projects for 4 different techniques. And then we knew the goal set already, so we were once the participants, for example, denoted where the which comment was useful, we knew then in which position. If they, for example, said that comment was in position 1, we then marked it and we checked it, is this same as the goal set? Yes, if so, and then that's how we computed the average position of recommended comments. So in this case, the highlighted yellow area column is actually our tool, which performed. We can see the average position is 1.8 against the VCM, which is 9.1. What that means is that for the same query that was entered for VCM and for VCM SA plus TR, the related comment or useful comment for our approach was in position 1 or 2, while for the baseline it was found to be in position 9 or even 10. And then we see sort of the similar ranking for combinations of VCM and SA and VCM TR. And this also shows the student t-test measures that we performed. So according to the results that we performed, our approach was significantly significant. The difference was significant enough compared to the baseline from the p-value we can see, and even Cohen's size was pretty high, so that just tells how different that was. And then for the user study, we performed a little bit different, we took a different approach. So we used the cross-validation design methodology, which is a common strategy in software engineering. And so we used a 40 real bugs report to evaluate our approach versus the baseline. And then we asked 20 participants, from which 10 of them were from industry and 10 from academia. And then they performed the tasks, bugs 1 to 20, as many as they could perform, and then we asked them to rank the comments based on how useful they were while they were trying to solve the bug. And so they usually, to do this task, we asked them to use 4 different open source projects, such as GCC, Eclipse IDE, Apache Server, and LibreOffice. So to rank the comments, how useful they were in helping them to solve a new bug, we provided the Likert scale from 1 to 4, not relevant, which shows that the information or the comment contained or did not contain any relevant information to query input. And then second one, somewhat relevant, was a score of 2. The information or the comments contained mostly lack details to references to other artifacts or links, or even explanations were done partially, and they provided limited clues. While the relevant ones and the highly relevant ones, they provided information, and it revealed specifically artifact links that trace the bug, and to some extent commit patches with partial explanations. By the highly relevant ones, they provided extremely useful details such as code snippets, sometimes in patches with diffs, links to duplicate bug reports, resolution steps, and change explanations. So based on the user study, we also performed here the metrics and statistical tests. And so we measure the mean ranking average of comments for both approaches. And as you can see, for our approach, participants ranked comments very highly. The average was 2.7 compared to the VCM, which was 1.4. And then obviously the p-value was very high, and then Cohen size was also very high, meaning that the difference between the two approaches were significantly high, and the hypothesis, of course, was rejected. So here's an example where we use the same input query, or at least a participant used the same query, and then ran that with two different tools. And this was a bug in GCC, and then the user query was implicit function declaration. So you can see that the query results returned by our approach, VCM, SA, and TR, actually provided not only very useful comment, but they were very related to the input query, and the way that the participant ranked them, it shows that it was between 4 and 3, while for the same input that the participant entered for the technique, using technique VCM, the queries were, or at least the rankings were between 1 and 2, or most of the time they were ranked as 1, meaning not informative at all. And so just I have to point out here that when the participants were doing this study, the GUI representation and the look and feel was same for both techniques. So they were not aware of which technique was implemented in which GUI application, because they looked equally the same. And this was just to avoid any biases while they were conducting the study. So as it can be noticed, our approach or results from our approach showed a stronger relationship with the content from the query input and bug description. So in all cases, the relevance score was either 3 or 4, but this was not the case with a baseline VCM, which did not show a strong relationship with the content from the query input and bug description. In fact, in all cases, relevance score was either 1 or 2 from all retrieved comments. So overall, we proposed a new technique for leverage semantic and natural language information to support bug fixing a bug, and we minimize the cost of software development and maintenance by increasing developers' awareness and their ability to an aspect of new bug effect, to understand non-behavioral aspect of a new bug effectively, their context to domain knowledge, and their relation to domain knowledge. And this concludes my talk. If you have any question, I would be more than happy to address them.